for that introduction. I agree science is hard work, but it's worth it for what you get out at the end. It's fascinating, it's exciting, and I hope that if you don't believe that now, in about an hour from now, you'll definitely share that opinion. So, as was said, my name is Dr. Frank Mayer from the University of Manchester. We've got a few latecomers at the back. Welcome. Just in time to hear my warnings, because we call this demonstration lecture the University of Manchester Flash Bang Show. So there is going to be flashes, there's going to be some bangs. I'll warn you about the ones I'm expecting, and I'll advise you to protect your hearing. This is your personal protective equipment. You put these over here when I've got bangs to warn you about. That way everybody gets out without getting damaged. There might be a little bit of smoke. If you're an asthmatic, that might help you. I think we've got a nice high ceiling here, so it shouldn't be too bad. And without further ado, really, I think I'll just dive straight in, because the purpose of this lecture, especially at this time of year, there's a great tradition in science to tell the public about the wonders of science around Christmas. It started off in the Royal Institution down in London. There's the Royal Institution Christmas lectures. They were started by a guy called Michael Faraday like 200 years ago, continue to this day. But you don't have to go to London. You've got a fantastic demonstration lecture right here at Hartfold today. So my purpose is to show you about the excitement and importance of chemistry. So first of all, chemists are in control of the atoms, and we can make what we need. If you want to make a Selfridges bag, you need some yellow colour. So we can take two completely colourless solutions and make some yellow pigment. And sometimes reactions are as fast as that. We can control not just whether the reaction happens, we can control how fast it happens. So here's one where, we'll give it a good stir. Lift it up. Initially, nothing happens, but then after a little while, maybe have to wait a while because it's quite cold today, so things happen slower. The molecules move around more slowly, so reactions happen more slowly. This one doesn't seem to want to happen at all today, and that might be our first failed reaction of the day, or it may just be that it's unusually cold, but I'm going to underline here that this isn't television. If this was the Institution Christmas lectures on telly, they'd have stopped it and done it again. But this is real. This is not special effects. This is live science. In that case, something got in there that shouldn't have been there and it stopped the reaction happening. So we'll move on. Either that or I got two lots of the wrong solutions in, but we shall see. We'll move on and see any more success. This one, yes, this is a bit better. We've got a very pale orange colour, but when I give it a stir, I get a nice blue colour. Now, I'm aware that we've not got the best visibility here, so I'll move up and I'll wind time backwards, and so that we can see that the reaction goes back to the beginning again, because we started off with a colourless solution. And then it went orange, and then it went blue. Right. So now this, what you should all be thinking, is anybody thinking, how is that happening? I've seen lots of chemical reactions before. They usually go one way or they go the other way. So that's blue, should eventually go colourless, yeah. And then orange, and then blue. Very good timing, sir. Now that is a remarkable reaction. There's not many reactions do that. Can't decide what it can do. In a sense, you've got some regularity there. You've got it ticking like a clock. And yet it's in a beaker with lots of molecules flying around at hundreds of miles an hour in a stirred beaker, chaotic system. All these molecules flying around, and yet that order comes out of that chaos. That is remarkable. Now, I'm not going to spend the time here to actually tell you. It will continue oscillating for a good 5-10 minutes before it finally gets where it wants to go. I'm not going to spend an awful lot of time telling you about why that happens. The point I want to make is the most important thing in science is that question, why. If you're wondering, how does that work, then potentially you're a scientist. If you're not bothered, then there's nothing we can do with you. All you need to make a scientist is to wonder why, and then you need to learn about how to find out why. And there's a lot of work goes in, but the most important thing is you want to be curious. Why does that happen? That's funny. That's the most important word in science. So if all I want to do is make a blue solution, then that's not a particularly great way of doing it because it can't decide what it wants to do. There we go, blue again. But there's a quicker way of getting a blue solution. I just start with a colourless solution and I give it a good shake. And if I do that and shake it hard enough, it should go blue. Right, we seem to like blue today. We've got two things going blue. Now, here's something that some of you may have seen a reaction a little bit like that before. In all these reactions, you saw me pour the solutions together. I added chemicals together and I got a chemical reaction. Here, you didn't see me add anything to it. All I did was shake it. But when I shook it, I was actually adding something to it. What was I adding into here when I shook it? Anybody? Excellent, so you have seen it before, oxygen, good. Because there's air up here, 20% of the air is oxygen, so when I shake it, the oxygen goes in here, and there's a detector in here, it's called methylene blue. It's a detector that goes blue in the presence of oxygen. Right at the end of the show, I'm going to show you some concentrated oxygen, and you'll see that oxygen is in fact blue. But for the time being, we know how to get a blue solution. We had oxygen from here. When I shook it, it dissolved into here. And liquids do dissolve gases. So, next one is almost the exact opposite, because we've got a solution here, which has got plenty of oxygen already in it. It's not just dissolved oxygen, not molecules of O2 oxygen, but what it has is water molecules which have been modified with an extra oxygen atom. I'm sure everybody knows that water's H2O, so what we've got in here is H2O2. HOOH, it's got an extra oxygen atom in. And it would really much rather be H2O, but if I put in, yeah, let's say it's Christmas, so we'll do 200 mils, right, okay. 200 mils of this stuff called hydrogen peroxide. Peroxide means it's got two oxygen atoms joined together. So this is H2O2 in there, in simple terms. And what I'm going to do is